Have you ever started to learn about a technology? You feel very confident at first, but then you are hit with those advanced topics and you just stop. Because you think that you have covered all the basics, you probably don't need these advanced topics. But you either feel difficulty clearing job interviews, and even if you somehow clear these job interviews, it becomes very difficult to sustain in that job. So it is very important to learn advanced topics as well. And what if I told you that you could learn these complex concepts very easily and without getting bored? So, hello everyone, welcome back to Tech World with Sahana. Today I'm back with another chapter in our Kubernetes Zero to Interview Hero series, where I am getting into more advanced topics with our Kubernetes Chapter 7 Ingress and HTTP routing. So, let's get started. This is a list of all the topics that we are going to cover today. So, let's start with our first topic Ingress Resource. In Kubernetes, an ingress is like a smart traffic manager that controls how requests from outside world reach your service inside the cluster. Normally, services are exposed using node port or load balancer, but those methods are either limited or cloud dependent. Ingress provides a more flexible and centralized way to handle HTTP and HTTPS traffic. Think of Ingress as a map that tells Kubernetes whenever someone visits this path or domain, send them to this service. It also supports advanced rules like routing by path, host name, TLS, SSL, etc. But remember, an ingress resource is just a set of rules. It needs an ingress controller like NGINX to actually make it work. Let's start with a very basic setup. Imagine we already have a simple service called My App Service running on a port 80. Now, we will create our first ingress resource to expose it. So, this is our YAML. Let's understand it. So, we have got this API version, networking K8s IOV1, which simply tells Kubernetes which version of the API we are using for this ingress. And this is the standard one in all modern Kubernetes versions. Then we have this kind as ingress, which means, okay, this YAML is defining an ingress resource and nothing else. Then we have this metadata. And under metadata, we are giving it a name like My App Ingress. This is how Kubernetes will identify our ingress object. Now, we also have something called annotation here. And here, we are using NGINX Ingress Kubernetes IO read write target : and then this slash like a root path. What does this do is it tells NGINX to rewrite the incoming path to root before sending it to the backend service. So for example, if a user visits /app, NGINX will forward that request to the service as just /. Then we have this specification section. This is where all the actual routing logic lives. Inside specification, we have rules, and these define how traffic should be handled. We don't specify a host here, which means this rule will apply to any host that matches the path. Now, under the HTTP, we have got paths, and that's where we define our routes. And in this case, the path is just like a root path, meaning all the traffic coming to the root will go to the backend service defined here. For the path type, we are using prefix. So URL that starts with / will match like something like /home, /about, and anything else. Finally, we have define the backend. Here it's pointing to a service named my app service on a port 80. So basically any HTTP request that comes in will be sent to the service running inside the cluster on a port 80. Okay, so to summarize this YAML defines a very basic ingress rule. Any HTTP request to this slash will go to the my app service on a port 80. And if NGINX is used, the rewrite annotation ensures paths are forwarded correctly and no host is specified here yet, so it applies to all the incoming requests. Next we have Ingress Controller. So an Ingress resource by itself is just a set of rules like we discussed. It does not do anything without an Ingress Controller. Think of Ingress Resource as a map and Ingress Controller as a traffic police that reads the map and routes the request. NGINX Ingress Controller is one of the most popular controllers, especially for on-premise Kubernetes cluster. It watches the Ingress resource and configures NGINX to route traffic according to the rules. Supports advanced features like TLS, path, host, routing, rate limiting, and much more. So without a controller, your ingress rule exists but won't actually route any traffic. So now let's check out how do you install NGINX Ingress Controller. So here's a simple way to install it using kubectl. We give this command kubectl apply -f, then this URL. This URL is nothing but it just points to the official NGINX controller deployment manifest. It's a YAML file that creates all the required Kubernetes objects like namespace, service account, roles, deployment, and service to install the NGINX Ingress controller in your cluster. For this topic, we don't need to change anything in the YAML that we discussed earlier. The Ingress resource will automatically be picked by the NGINX controller once it's deployed. So to summarize it, Ingress is like the rules and NGINX Ingress controller is the engine that makes the rule work. Now the next topic that we have is path-based routing. So what is it? It allows you to route your traffic to different services based on the URL path. So suppose if the traffic comes to /app1, it goes to app1 service, and if the traffic comes to /app2, the traffic goes to app2 service. This is useful when you want to expose multiple services under the same domain. So now let's extend our original ingress to include these two paths. So we are taking the default YAML here, which we discussed earlier. And you can see we have updated a few things here. Since this is path-based routing, we are focusing on the path fields. For the first route, we have set the path as /app1 and we want any request coming to /app1 to go to app1 service. That's what this particular section is doing. Then we have added another route for /app2, which will send all the traffic coming to /app2 towards the app2 service. The path type we are using here is prefix, which means any URL starting with /app1 or /app2 will match these paths and be forwarded to their respective services. App1 service and app2 service. Okay, so the next topic we have is host-based routing. So host-based routing allows you to route traffic to different services based on the domain name. Like if traffic coming to app1domain.com, it goes to app1 service. And if traffic is coming to app2domain.com, it goes to app2 service. This is especially useful when you host multiple applications under the same IP but different domains. Let's see how we can achieve this with the YAML. So you can see we are adding a host part for each rule. When a request comes, Kubernetes first checks the host header in the request to see which domain it's meant for. Once the host matches, it then looks at the path under the host to decide which service should handle this. After matching both the host and the path, the ingress forwards the traffic to the corresponding backend service, which then routes it to the right pod. This way, we can handle multiple applications under the same ingress and each on its own domain. Also, it keeps the traffic for every service cleanly separated. Next topic we have is TLS termination with secret. So TLS termination means that the ingress handles HTTP connections by decrypting SSL TLS traffic at the ingress level. So your backend service receives plain HTTP request, right? So now the encryption or decryption happens at the NGINX Ingress Controller, and Kubernetes stores the TLS certificate in a secret. Okay, so now let's check out how can we create a TLS secret. Suppose you have a TLS.crt, your certificate, and TLS.key, your private key. You can create a secret with this command: kubectl create secret and this part. This my app TLS is the name of the secret, --cert is the path to the certificate, and --key is the path to the private key. So now we will extend our original Ingress YAML file to include this TLS part. So we are taking that default YAML only, and you can see we have added a TLS section here. Since this is for HTTPS, we are focusing on the TLS block here. For the first part, we have set the host as app1domain.com and app2domain.com, which means any requests coming to these domains should be secured with TLS. That's what this part is doing. Then we have added the secret name field, which points to the my app TLS. This secret contains the certificate and private key, so the ingress know how to encrypt traffic for those hosts. So basically what this section does is it tells Kubernetes, hey, any traffic coming to these hosts, use HTTPS, and here's a certificate you need to make it work. The next topic that we have is HTTP to HTTPS redirect. So by default, your HTTP traffic can still reach your services even if you have TLS configured. To make sure everyone uses HTTPS, we add an annotation in NGINX. And here's what it looks like. The key part is this one. Force SSL redirect is set as true. What this does is very simple, that if someone tries to reach your service over HTTP, NGINX will automatically redirect them to HTTPS. So now, no matter how users try to access your application, they will always end up on the secure version. Now let's check out this YAML. We have added the annotation part here, right? So the rest stays the same, which we discussed earlier. No other change is required. TLS is configured for app1domain.com and app2domain.com, and requests are routed to app1 service and app2 service based on the host. So what actually happens is, now suppose if any traffic is coming to HTTP app1domain.com or HTTP app2domain.com, it will automatically redirect to HTTPS, keeping your traffic secure without users having to type manually HTTPS. Now let's understand What are wildcard domains? A wildcard domain allows you to secure multiple subdomains using a single TLS certificate. For example, suppose we are using a wildcard domain in TLS configuration. A wildcard domain is written something like anything.domain.com, and it allows a single TLS certificate to secure all subdomains under that domain. For example, anything.domain.com will cover app1domain.com, app2domain.com, apidomain.com, and any other subdomain you create. This is especially useful when you don't want to create separate TLS secrets for every subdomain. One wildcard certificate handles them all, keeping your configuration simple and secure. Now, let's check out the YAML. Here we are updating the Ingress to use the wildcard TLS certificate. The TLS section now lists anything.domain.com, which means a single TLS secret, suppose my app TLS, will secure all subdomains under domain.com. The routing rules for each host, like app1domain.com and app2domain.com, still works exactly the same. When a request comes in, NGINX first checks the host header and then the path to decide which service should handle it. This way, you can secure multiple subdomains with one certificate while keeping traffic for each application separate and organized. Next topic we have is default backends. So what is it? A default backend is a service that handles any requests that don't match any of the rules defined in your ingress. For example, if someone visits an unknowndomain.com or some random path and there's no specific host or path rule for it, the default backend will take care of the request. It's often used to serve a 404 page, a maintenance page, or a simple message indicating that the request resource does not exist. This way, even unexpected requests are handled gracefully, and users don't see connection errors or timeouts. Now let's check out this YAML. Here we are adding a default backend at the top level of the Ingress specification. The default backend points to the service. In this case, default backend, which will handle any request that does not match a host or a path rule. The rest of the ingress works the same. TLS is configured with anything.domain.com, traffic for app1domain.com and app2domain.com still routes to respective services. This setup ensures that even if someone visits an unknown domain or an invalid path, there's a service ready to respond, often with a 404 page or a maintenance message, keeping the user experience clean and predictable. Next we have is rewrite rules. So a rewrite rule lets you modify the URL path before the request reaches your backend service. For example, a user sends a request to app1 page 1. You want your service to receive page 1 instead of app1 page 1. This is especially useful when your service expects request at the root path rather than under a subpath. By using rewrite rules, you can keep your service simple while still supporting multiple paths in your ingress. Now let's check out this YAML. Here we are updating the ingress to rewrite rules so that the backend service sees the path the way it expects. The rewrite target /$2 means that NGINX will remove the /app1 or /app2 prefix from the incoming request before sending it to the service. In the path section, we use a pattern like this, and these are regex patterns that captures everything after /app1 or /app2. So the rewrite rule can forward the correct path to the backend. This way, the requests like /app1 /page2 are rewritten to /page1 for the service, letting your backend always work from the root path, while the Ingress handles multiple paths cleanly. Next we have is rate limiting. So what is it? A rate limiting controls how many requests a client can send to your service within a certain time period. For example, you might allow 10 requests per minute per client. This helps protect your service from being overloaded and maintain a smooth experience from all users. With rate limiting in place, clients that exceed the limit will receive an error response until the time window resets, ensuring your backend stays safe and stable. Now let's check out this YAML. We are updating the Ingress to limit how clients access our services using NGINX annotations. The limit connection 5 annotation ensures that each client can have at most 5 concurrent connections. While limit RPM is set to 60, makes sure that no client can make more than 60 requests per minute. This way, if a client tries to overload the service, their extra requests are automatically restricted, protecting the backend and keeping traffic smooth for everyone. Next topic that we have is CORS handling. CORS. Cross origin resource sharing. This allows your service to control which domain are allowed to access its resources via JavaScript running in your browsers. For example, if you have a front-end application hosted on frontenddomain.com that needs to call an API on apidomain.com, CORS ensures that the browser permits the cross-origin request. Without proper CORS settings, the browser would block the request, preventing the front end from communicating with the backend. By configuring CORS, you can safely allow specific domain to interact with your service while keeping others restricted. Now let's check out this YAML. So we are updating the Ingress to enable CORS using NGINX annotation. The enable CORS is set to true. This annotation turns on the CORS for this Ingress, while the CORS allow origin is set to frontenddomain.com. This specifies which domain is allowed to access the service. The CORS allow method annotation would list the HTTP methods that are permitted, and the CORS allow headers define which headers the client can send. Finally, we have this CORS max age, which is set to 172.8.0.0. This sets how long the browser can cache the results of the pre-flight request. Together, these settings allow a front-end hosted on frontenddomain.com to safely communicate with the backend service while controlling access and keeping your request secure. So we are going to discuss multiple failures and fixes in our daily module as well. But in this video also, let's discuss the top 5 common issues for Ingress. So the first one that we have is, suppose even after creating your Ingress, traffic might not flow as expected. So the one common reason is that the NGINX Ingress controller might not be installed or running properly. In this case, Kubernetes cannot route requests because there's no controller to handle the Ingress rules. You can check the status by running kubectl getpods-n ingress-nginx command to see if the controller pods are up and running. The next is another frequent issue is that the DNS or host resolution problems. If the host defined in your Ingress does not match the host in the request, traffic will not reach your servers. To fix these type of issues, ensure that DNS records or your etc host file points the host like app1domain.com to the Ingress controller's external IP. Next is an TLS error. This can also prevent traffic from reaching your application. This often happens if the secret is missing, misconfigured, or the certificate does not match the host. You can verify the secret with kubectl describe secret my app TLS and ensure the certificate covers all the intended host or wildcard domains. So the next one that we have is sometimes path rewrite doesn't work as expected. This usually happens when the rewrite target annotation is missing or the regex in your path is incorrect. Double check that your annotations such as this part matches the path defined in the ingress so that the requests are rewritten correctly before reaching the backend service. Finally, the last issue that we are going to discuss is the issue with course or rate limiting. This often occurs due to missing annotation or incorrect values. For example, if course headers are misconfigured, browser will block cross-origin request. Similarly, an incorrect set limit RPM or limit connections may block legitimate clients. The fix is to carefully verify that all annotations are spelled correctly and have valid values according to the NGINX Ingress documentation. So now let's discuss the top 3 ingress commands that will be very helpful to us. The first one that we have is kubectl get ingress. This lists all ingress resources in your current namespace. The host column shows which domain each ingress handles. The address column shows the IP of the NGINX Ingress Controller or load balancer. The port indicates the exposed ports, usually 80 for HTTP and 443 for HTTPS. The age shows how long ago each ingress was created. The next command that we have is describe ingress. This command shows the configuration detail for the ingress named my app ingress. It includes its namespace, IP address, TLS configuration, routing rules, annotations, and recent events, which help confirm that the NGINX Ingress controller has properly synced the resources. The next one that we have is to check the NGINX Ingress controller logs. This logs command confirms that the NGINX Ingress controller has started successfully, detected your my app ingress resource, applied rewrite and course rules, enabled SSL redirection, and updated the ingress status with the controller IP. So that is it for this video. See you in the next one.